Hi, I'm Luke Cronin, and this is the Effortless Opener 5000, a garage door motor controller with Bluetooth connectivity. It connects to any Android-enabled Bluetooth device and features an onboard push button and Bluetooth indicator LED. It has an operating range of about 30 meters and connects directly to a wall outlet so it can constantly be powered and be constantly at your convenience to open your garage door. This device features four main components: a push button, an Arduino Uno, an HC-06 Bluetooth module, and a relay. The device is powered via USB-A to USB-B cable, which then connects directly to a 10-watt power brick, which then connects directly to a wall outlet. The push button works by sending a short signal to the Arduino Uno, and then the Arduino Uno will then trigger the relay to either open or close, which sends a short pulse to the garage door motor, triggering the door to either open or close depending on its previous state. The HC-06 Bluetooth module receives commands from a mobile device via serial communication. The Bluetooth module then communicates with the Arduino Uno via, again, serial communication, and depending on the command, it will either turn the relay on or off, triggering the garage door to open or close. Here's the schematic that was created for this device. We first had the Bluetooth module, which is powered by the 5 volts on the Arduino. It is then connected to the RX and TX pins of the Arduino. The TX pin is connected to a voltage divider to step in the voltage so that the Bluetooth module can receive a safe signal without being damaged. Next, we had the relay module. The relay is connected to a diode and an NPN BJT transistor, which is then connected to pin 13 of the Arduino. The transistor is used to amplify the current so that the relay can actually open or close, since the Arduino does not supply enough current. This relay is then connected to a screw terminal, which will then connect directly to the garage door. We then have the LED, which is simply connected to pin 8 of the Arduino and a 220 ohm resistor, and the push button, which has a 10K pull down resistor, is connected to 5 volts, and then pin 2. Your garage door opener will look something like this. This mounts directly to the wall via an adhesive, which will be shown in the demonstration, and features a light and compact design. On the front, we have a USB connection for power or an optional barrel jack for a connection. On the front, we have a Bluetooth indicator LED and the open and close button. Here we have some branding indicating that it is a garage door opener and the ECE 5000. Here we have some ventilation for aesthetic, and on the top we have two cutouts which will be for the wires that connect directly to the garage door. Here's the enclosure. It is two pieces, both a lid and a box, which actually houses the Arduino. The lid has cutouts indicating the garage door, the Bluetooth indicator LED, and an open or close button. We have some ventilation here, which is just for aesthetics, as the device does not reach high operating temperatures. And we have M3 screws here to actually attach the lid to the box. On the back here, you can again see the cutouts for the button and LED. These are secured using hot glue to prevent contacts from the leads touching, and also to prevent the button falling out when it is pressed or if the Bluetooth button is pressed. Next, we have the box itself. Within the box, you can see mounting pins for the Arduino, and we have cutouts for the USB and a barrel jack connection. On the back, you can see two cutouts which are for the wires for the garage door. The enclosure itself is custom 3D printed using red PLA material, which is durable and very lightweight. The core of this device is a custom-made printed circuit board. The circuit board can be seen here, and it features all the core components shown in the circuit diagram. We have the relay, the NPN BJT, all the required resistors, a diode for protection for the relay circuit, the Arduino pin headers, the 4x1 connector for the Bluetooth module, and the screw terminals, one for the button, one for the garage door itself, and one for the LED. The Bluetooth module just fits in like so and rests flat on the device. Here's a blank version of this circuit board, and we will not go into details as this is not required for the operation of the device. The device simply plugs directly into an Arduino Uno, and then the device is mounted within the enclosure. Here's the device out of the enclosure. As you can see, the PCB reduces many of the wires that were in previous design iterations, and it also makes the device much more compact. Here's the device itself mounted into the enclosure. As you can see, there are very few wires, and the extra space is for the wires that will be connected into the screw terminals. The PCB drastically reduces the size and greatly enhances the cable management. To determine the mechanical specifications of this device, a complete 3D model was created using SolidWorks. We first have the Arduino Uno, then we have the shield which attaches directly to the Arduino Uno, and then we have the enclosure itself. From this 3D model, precise dimensions were determined along with mass properties, which will be shown in the next clip. Here we can see the mass properties of the device. As mentioned in the brochure, the device is approximately 225 grams, which can again be seen here through the SolidWorks calculation. Here's a drawing for the device. The dimensions of the device are 110 by 85 by 52. The screw sizes of the device are M3, and the cutout for the wires that connect to the garage door is about 6 millimeters. To verify the electrical specifications as per the brochure, I'm using a multimeter connected in series with the power supply that is currently powering the device. In this case, I'm using the 5-volt and ground pins from another Arduino to power this device using its V-in and ground pins. I have all the main current consuming and power consuming devices connected, such as the Bluetooth module, an LED, and the shield itself. Right now, we can see that the device is consuming 30 milliamps, and this is with no Bluetooth device connected and the LED off. If we then connect a Bluetooth device, we will see the current peak to 0.4 milliamps. Then it settles back at 30 milliamps. As mentioned in the brochure, this device will consume a maximum 42 milliamps, which was verified using a more precise multimeter. We can see that the device is now connected by the Bluetooth module and the LED turning on, and the device is actually only consuming right now 20 milliamps. Code for this device is fairly simple. We begin by defining the pins for each specific component connected to the Arduino, so the relay, the button, and the LED. We then create a char called value, which will store the commands sent from the Bluetooth module. We then define the inputs and outputs, the relay is an output, the button an input, and the LED an output, and we begin the serial on the Arduino. We then jump into the loop, where we have an if statement checking to see if the button is pressed. If the button is pressed, we will set the relay to low and then high.
which will then send a short pulse to the garage door, triggering it to open or close. We then jump into the code for the Bluetooth module. As I mentioned earlier, the Bluetooth module communicates to the Arduino via serial communication. The Bluetooth module will either send a 1, 3, or 4 to the Arduino Uno via serial communication. When a 1 is received, the relay will close and open, sending a short pulse to the garage door motor, which will either open or close the garage door. A 3 is sent to the Arduino when the Bluetooth module has made successful connection to a mobile device. This will then set the LED to high, indicating to the user that they have successful connection to their mobile device to the garage door opener. When there is no longer a successful connection, the Bluetooth module will send a 4 to the Arduino Uno, which will then set the Bluetooth indicator LED to low, indicating that there is no longer a device connected to the garage door opener. The mobile application that controls this device was created using MIT App Inventor. First, a user interface was designed. We have a connect device button, an open close button, instructions on how to connect your mobile device to your garage door opener, and a disconnect button. How this application actually works is very simple. We first have a list picker, which allows the user to connect to specific garage doors in case they have more than one. Next, after selecting which garage door that the user wants to connect to, we change the list picker button to say connected, and we change it to the color green, giving a visual indication that the device is now connected to the garage door opener. We then send a 3 to the Arduino Uno, which will then trigger the Bluetooth indicator LED to turn on. Now, if the open or close button is pressed on the application, we will send a 1 to the Arduino Uno via the Bluetooth module. This will then trigger the relay to open or close, sending that short pulse to the garage door motor, then causing the garage door to open or close, depending on its previous state. If the user decides they want to disconnect their mobile device from the garage door opener, we will send a 4 to the Arduino Uno. We will then call a Bluetooth client to disconnect, and then we will set the connect device and the disconnect button back to their defaults.
To install your new garage door opener, you'll first want to remove the manufacturer's garage door opener and attach these two wires, which are typically attached to the back via a simple screw. These two wires connect directly to the garage door motor, and nearly all garage door openers operate the same. Once these two wires touch together, a very short pulse is sent to the motor, triggering the door to open or close. Once you have the two wires exposed, you can mount your new garage door opener to the wall via an adhesive such as tape and remove the lid. Once the lid is removed, these two wires will connect to either screw terminal of this device right here. Once you have these two wires connected, you can put on the lid. I now have the two wires connected to the screw terminal of the device as shown here, and they are mounted through the two cutouts that are meant for these two wires. These two wires do not have polarity, so it does not matter which wire goes in which screw terminal socket. So you can flip them around and the device will still function the same way. Once you have the lid placed back on the device via the included M3 screws, you can go ahead and plug in the device via a USB-A to USB-B cable, which then plugs directly into a 10-watt power brick and plugs directly into a standard wall outlet. Now you can go ahead and connect your device to a Bluetooth enabled device. So you'll first want to head to the Bluetooth settings on your phone and find HC-06. Once pressing this, you will be prompted to enter a PIN, and for this specific device, it is 1234. Once the device is paired, you can go ahead and head over to the Garage Door Opener app, which will have the MUN Engineering logo as seen here. You can open the app, and we will see the user interface when there is no device connected. We will see the connect device button be blue and the disconnect button be gray. If we try pressing the disconnect button or the open and close button, we'll be given an error since we don't have the device actually connected yet. We can head over to connect device and select the garage door that we want to control. I will select HC-06. Once there is a successful connection, we will see the user interface change. We will see the connect device button change to connected, and we will see the disconnect button turn red. Also, you can notice successful connection by the Bluetooth indicator LED turning on right there. Now you're fully connected to your garage door opener, and you can go ahead and open or close your garage door via this mobile app. Pressing open or close first opens the garage door, pressing it again stops, and then pressing it again closes. Then if you did want to disconnect from the device, you simply just press disconnect. We will see the user interface change back to the default, and we will see the Bluetooth indicator LED turn off. If you did need to operate your garage door without a mobile device, there is an included push button for manual operation. Just press that, and your garage door will function the exact same way it did as the manufacturer's garage door button works. Pressing it again stops, and then pressing it again will begin to close the garage door. As mentioned in the brochure of this device, the device has an operating range of about 9 meters or 30 feet. As you can see, I'm outside my garage here, and I'm well above 9 meters or 30 feet from the device itself. I'll first connect to the device through my smartphone, and I'll notice successful connection by the user interface changing. If I then press open or close, you'll notice that the garage door motor begins to close the door, and if I press this again, we'll see the garage door open again. This concludes my device demonstration. If you have any questions, feel free to reach out to me at my email listed on the screen, and thank you all for watching.